All right, just going to hand over, hang on a sec, hand over to you as host. You should now be able to share your screen, John.
Thank you, Michelle. I think everyone should be able to see my screen now. Is that correct?
Yes, we can.
Michelle, thank you.
Yep.
Thank you. Thank you all for joining today. Title of today's presentation is Falls on Steps and Stairs, and I hope to maybe bring you some insight as to how we investigate falls on stairs and what are the leading causes. So just to start off with, I think I just need to go through some terminology that we'll be using through this presentation. The first is the nose or the nosing. This is the area here at the leading edge of the step where most people place their foot as they're going down the step. The second is the going dimension, and that is the horizontal distance between the nosings from one step to another. And then the third one is the rise or riser, and that is the vertical distance between the steps. And these terms are used throughout industry, through our building codes and standards. So it's sort of good to be familiar with the terminology when reviewing reports and looking at expert reports and so forth. Now, getting straight into it, what initiates falls on stairways? There's three main causes, and one is a slip, and that is when there's a lack of traction underfoot, either during ascent or descent. Then you have a trip where the foot, the heel or the toe gets caught on the step, again during ascent or descent. And then you have a misstep, and a misstep is typically where the foot isn't placed on the step correctly and the person cannot transfer his weight accordingly to the step, and that causes either a slip or a trip or a combination. Now, we'll move on to slips during ascent. Now, that typically occurs when one is trying to push off and move up a step. The foot typically will slide backwards off the edge of the step, and it will cause the person to fall forwards, landing face first on the stairway itself. These type of slips are not common, but they're common enough that we do investigate them on occasion. However, typically the resultant injuries are not significant because there's not, obviously the distance someone falls is not significant. With respect to slips during descent, that occurs when the foot lands on the tread and a weight transfer occurs. So as you place your foot on the step down, you basically are relying on the grip between your shoe and the step to hold your weight. If there isn't enough grip on that tread, then what will happen is your foot will slide off the front of the step, and this will tend to lead to a fall where you basically are going feet first down the stairway. This is probably the most dangerous slip, dangerous type of fall, because it can result in the person falling all the way down the stairway. Now, with respect to the frictional characteristics of the surface, we can obviously test and assess what they are using a number of instruments. One is the Stanley pendulum, which is shown here on the left, and we can assess those test results that we get on the stairs with relevant standards and general codes of practice. There are other tests that are called for, but they can't be done on site. One is a German ram test, which typically cannot be done, obviously cannot be done on site. And also it is very difficult actually to do any form of slip test on stairs because of the nature of the equipment and the size of the step and the dimensions of the steps. So as you can see here, we've actually tried to use some pieces of wood to get the machine to actually be able to test on the nosing area, which is the relevant section of the step. Just moving on to trips. Trips during descent occur mainly as the foot here travels down. It will make contact with the nosing of the step here, and basically that can cause a person to fall headfirst down the stairway. Now, the main reason a trip like this can occur is predominantly the going dimension is larger than the preceding dimension of the steps, and that irregularity causes the person to misjudge the position of the nosing of that step. Now, another trip can occur basically during ascent is when the foot is going up to the next step. It misjudges the height of the step and makes contact at the toe area. This again causes the person to trip forwards and onto the step. And the main issue here is there's the riser height is larger than the preceding step. So again, people rely on steps which are consistent in shape and size, and if there's any irregularity in the step dimensions, that can lead to a person tripping on the steps. Now, the last one here is misstep. Now, this is probably the most common occurrence that we find when we're investigating falls on stairs. It is when a person basically lands their foot on the step. However, what happens is their foot doesn't make contact correctly. It's basically a misstep or overstep. And what happens is their foot then slides down the front of the nosing of the step. Many people will describe that they have slipped on the step because that is what they feel, that their foot has slipped. However, the slip has occurred due to an overstep, not because of an issue with the traction of the step. And slips like this can occur even on stairs which are dry or carpeted. Again, the issue typically relates to the dimension of the step tread being smaller than the preceding step, which means that a person anticipates a step being larger than it is, and it will cause them to overstep.
Just before you go on, John, I'm sorry. We've got a couple of people who've just joined the meeting. Would you please mute your microphone? Thank you.
Thanks, Michelle. Now, just to go on a little bit more about missteps. The reason people misstep is basically because their position of their foot on the going is related to the size of the going. You can see here with a typical 250 millimeter going, which is the BCA standard, most people rely on the nosing section for grip. Whereas if the nosing or the going is 350 millimeters long, their foot placement is well behind the nosing. You can see in this image here that person is using the nosing section and their foot overhangs the step tread or nosing, and that's typical of a normal descent down a stairway. But it does highlight that the position of these strips or grooves in the step are in the wrong position because they're not being utilized by people who are actually using the steps. Now, the risk of an overstep is dependent on the dimension of the step. So here we have a table which says a going dimension of 225 millimeters. You expect an overstep to occur every 4 years. But if you increase that going dimension to 250, which is the BCA minimum, the building code minimum, the overstep risk is reduced, and you may expect an overstep every 11 years. Now, typically what that's telling us is the larger the going, the safer the step. Also, I'd like to point out, if there's a variation between the steps, for example, if one step is 250 millimeter and the following step is 235 millimeters, or a 15 millimeter variation between the step, what that does is there's a significant increase of a risk of an overstep, nearly 5-fold. So you can see here a small variation, which typically isn't visible to a person descending, in terms of they won't be able to identify a variation of 15 millimeters by just looking down at the steps. You can have a significant increase in the risk of an overstep and the risk of a slip and fall. So consistent going dimensions basically means you're going to have a safer stairway. So there's the difference in risk, 5 times different increased risk of a fall. Now, here's an example of a flaw in a stairway that we've measured. So the top step here, or the preceding step, was measured at 310 millimeters. The step on which the person slipped on measured only 230 millimeters. That's a difference of 80 millimeters. Now, going back to the table that we showed previously, you can see there's a significant increase of an overstep occurring here. And we identified that the main issue here was obviously the difference in riser dimension in combination with the actual small going dimension of 230 millimeters. It also shows, this photo also shows a tool that was developed by myself to measure the step dimensions accurately and precisely, and be able to quickly identify differences in the step sizes and do it accurately from one step to another. With respect to the standards requirements, with respect to dimensions and variations, the building, there are various standards applicable depending on the type of stairway. The BCA, Australian Standard for Disability, and also industrial stairs, which is AS 1657. The riser and going dimensions vary depending on the applicable code, but variation between steps is almost consistently 5 millimeters is the largest variation allowed. There's also variations in the number of handrails required in the different stairways, and also contrasting nosing strips. So one of the other main aspects we look at when investigating a fall was the design and of the handrail, or if a handrail was fitted and how many handrails were fitted. So we might look at the shape, its diameter, how much clearance it has between the wall and the handrail. Is it continuous? So is there any break in the handhold? Are they fitted on both sides? And the height of the handrail, is it within easy arm's reach? Another factor we consider is the vision or lighting. Vision, obviously, if we can't see where we're going, we won't be able to place our foot correctly. And lighting, obviously, is the main key factor here. Light levels can be assessed. There are standards which we can use to measure and assess the lighting levels on stairs. Another factor is the edge delineation. How well is the edge highlighted? Other factors we may look at is adaptation and glare, which is change in lighting, darker from lighter to darker, or if there's a bright light source which may cause a person to momentarily not be able to see the stairs properly. Other things might be distractions and the usage of the stairway. Here's an example of the importance of lighting with respect to entrance here of a house. You can see that the difference between the effect that lighting can have in masking the presence of steps and their position in a walkway. Another example here is the importance of edge delineation. Obviously, well, not obviously, but it appears there might be a number of steps here, but actually the number of steps is actually 5, which may be difficult for someone to see, especially under low light conditions. So obviously stair nosing and delineation is important, as is lighting conditions. Also, the design of the nosing is important. The color contrasting, how sharp it is, the profile of it. The sharper the profile, the better. And does it have slip resistance material around the nosing area, or is it finished in a smooth finish? Now, another aspect of steps that we investigate quite regularly is the single steps. Single steps are a major source of accidents, mainly because they're sometimes difficult to perceive. And the factors around that are familiarity with the area, if people are familiar with the area or not. So a step where they're not expecting a step. Also visual cues, such as handrails and contrasting nosing strips. The other factor is distractions, and distractions may be of various types, because one must also consider, are these steps in a shop where the distractions are the merchandise on display, or other distractions such as stepping out into traffic or going through a doorway. So a person may not be obviously always aware of a single step. So here's an example of a single step where the step may be difficult to perceive in one direction, but not in another. And it's also placed in a doorway where one is not expecting a step to be positioned. The last aspect, I suppose, with respect to investigating falls is something known as line of desire. It's basically the people like to take shortcuts. So it's a factor that must be considered when investigating any incident, is what's the likely path a pedestrian is going to take? Are they going to use the steps correctly, or are they going to try to take a shortcut or try to do something unexpected with respect to the design? Now, when investigating or when taking instructions from any potential clients, it's important to ask some key questions with respect to their accident, such as the direction of travel, the exact location of the incident. Was it at the top? Was it in the middle or the bottom? Description of the fall mechanism. Did they slip? Did they trip? And how did they fall? Were they holding onto a handrail? Were they required to carry anything? Was there any contamination of the surface? Also the illumination levels at the time, and also their footwear. All these are factors that are likely going to be important later on, and getting a good description of these helps investigations later on. So what we do when we go out and investigate an accident, we will obviously measure the riser and going dimensions. We will measure the number of handrails and its position. We may also take illumination measurements, both at the steps and also surrounding areas. We will also look at the contrasting of the nosing, and possibly do some testing to measure the contrasting, the illuminance contrast. We'll measure the radius of the nosing, which is an important aspect of any tread design. We'll look at the materials used on the treads and evaluate the slip resistance if we can. And we also look at the design and layout of the stairway and steps, the position of the landings, position of any doorways, etc., to try to understand what were the factors that led to the accident occurring. Now, just a little bit about engaging any expert to do this type of work. I suppose with us, we always recommend you talk to us at an early stage. And obviously we can then help in trying to determine what the factors were before a view or any proceedings, go much further to see if there's any issues with the stairway. We hold regular meetings or weekly meetings with our staff to be able to look at various inquiries and see if there's any issues with the stairs, so we can advise you accordingly. So with respect to that, send the necessary documentation, photographs and descriptions. We can discuss likely site requirements and organise the site view carefully. If the accidents happened at night, then it's likely that we want to see the stairs at night to make or take illumination measurements in the area. We also have a number of free resources available on our website to be able to assist in gathering the information which is important at the time, to be able to assist us and yourselves in establishing what happened and what the main issues are. So we've got various items from manual handling, slip, trips and falls on stairs, and we can use this information to better assess the issues. I think that's all for me. Now I suppose I'll leave it open for questions and answers.
Thank you so much, John. That was fascinating, actually. Who would have thought that something as simple as stairs that we all walk up and down every day can actually be so incredibly complicated and potentially dangerous? I must say, when you talked about that edge piece on the nose piece being flush, I had always thought that they were supposed to be slightly sticking up, but now I realise that would cause another opportunity for someone to catch their shoe and slip. So that was really quite interesting. Thank you so much. Does anyone have some questions that they would like to ask? Now is your time to unmute yourself and jump in. Now, don't be upset, John, because what I find when this happens is that it's because the presentation you gave is so great that you answered all the questions people were going to have.
Let's hope so.
Everyone, I would like to thank you very, very much for joining us for this talk, from which I personally learned a great deal, and I hope you did too. Within a couple of days, the slides will be sent out to you with the recording. We hope you join us for our future seminars, and thank you so very much. Oh, great presentation came through on the chat. There you go. It really was. That was awesome.
Right,
and nice and simple too, and you didn't use too much scary engineer language, which is good for people like me who aren't that smart.
No, that's all. Thank you. Thank you
Thanks
all.
so much. Have a great day, everybody. Bye-bye.